Let's start recording this. Okay, so we're going to be talking about what's going to be on our next topic. And our next topic is matrices. How many people have done matrix operations and matrix before? Okay, about half. Okay, so this should be some familiarity. The ones that have not, they're actually really fun. Okay, so our next topic, we're going to look at matrices. In fact, I think I titled this topic matrix operation. So the title of this concept topic is matrix operations. Matrix is just the singular of matrices is the plural form, so it means the same thing. All right, so a matrix is just an array of numbers. Okay, it's just, it's a simple way to organize information and numbers or large data. Does anybody know where we use matrices in real life? Any idea? Computer science is very popular. Absolutely. Your matrix in your computer program and your computer sciences, that goes constantly. You're doing arrays, you're doing matrices every time in those. Outside of the computer programming, you'll also see it in a lot of businesses or a lot of different organizations where they have a lot of variables, a lot of different things that change. One common one is, say you have this large car company, a car dealership, and they have, say, multiple dealerships in like maybe 4 or 5, like Everett's or something, dealership that has like 4 or 5 different dealerships at different places in Arkansas. And then they want to look at what they have in stock. So they look at how many of this one type of car they have at dealership A, and they look at how much they have at dealership B, how much at dealership C, how much at dealership at E. And then they have, probably 40, 50 different brands, different types of cars at each dealership. You have lots of cars at each dealership. And then maybe they want to look at how are these types of cars selling at different locations. So then they want to look at how many cars they sell in 1 month, how many cars do they sell in the next month by type. And then they want to figure out which one is selling better in which area. So maybe in some areas, Jeeps sell more. So they want to ship more Jeeps to that dealership. And maybe in another area, maybe Little Rock doesn't get as many Jeeps. And so maybe they want to do more more like cars, basic cars for city driving. And so that's a lot of information. And they just list it, it's very hard to see. But you put it in a matrix, and you can easily look at it, you can easily manipulate with it. So it allows you to work with large data. Also involves in like businesses that have different variables that affect their profit line, such as how much does it cost for employees to work there? How much does your electric bill cost? How much does it cost to fix machines? How much do you have to pay for machines? All these different factors affect your profit. And so this matrices lets you solve systems of equations with lots and lots of variables. And that's what we're going to work on. So that's the goal that we'll get in when we end this matrix units, is we're going to look at solving larger systems of equations. We're only going to go up to 3 or 4 variables. But we're going to look at it. It's an easier way of solving some bigger systems of equations is what it's used for. But that's later on. Today we're just going to look at basic, what a matrix is, what it's called, and how we can do some basic operations, adding, subtracting, multiplying matrices. So first off, a matrix, like I said, is an array of numbers. This is a matrix. So just have an array of numbers is a matrix. Traditionally, matrices are named by capital letters. So you'll often see this is equal to matrix A. So you'll see matrix A equals this. Sometimes, and this is how a lot of things do it, you will also see this notation, bracket A, matrix A. So matrix A, or just a capital letter A, means the same thing. They both represent that matrix A there. Okay? Next thing you need to realize is that this matrix, if I go across, this is a row. Going across here is a row. So row 1 has the numbers 1, 3, and 5. Row 2 has the numbers 9, -2, and 4. Going down are columns. This is column 1, this is column 2, this is column 3. So going down, so column 1 consists of the elements 1 and 9. Column 2 has the elements 3, -2, and column 3 has the elements 5 and 4. Okay. Now, as I just said, a single entry in a matrix, if I'm looking at this number here, this is called an element. So a single number inside a matrix is called an element. And we would say the placement of this element, so 4, is in the placement of matrix A. It's in the second row, third column. So if I asked you to find the element A, 2, 3, that would be the number 4. So, and again, we're not uniformed on notations. I hate that we're not uniform notation. This is the most popular notation, but some textbooks take out the parentheses. Your textbook is one of those. It just writes matrix A, 2, 3. And that you need to read that you need to identify this at the row 2, column 3 spot. Okay, so it's the element that is in the row 2, column 3 spot. Okay, so what is our element A22? -2. Row 2, column 2. So it's -2. What is our element 1, 3? 5. Okay. Questions on finding the elements of a matrix. All right. You will also be required to identify the dimensions of a matrix. The dimensions are always listed row by column. So matrix A has the dimensions 2 rows, 1, 2, 3 columns. So it's a 2 by 3 matrix. So this example, matrix A here is a 2 by 3 matrix. Notice when we say it, we usually leave out the dimensions, the word dimension. Usually just say matrix A is a 2 by 3 matrix. And that means its dimensions are 2 rows by 3 columns on that. So let's look at another example. Let's call this matrix C. Okay, what are the dimensions of matrix C? We have 1, 2, 3 rows, 1, 2, 3 columns. So it's a 3 by 3. What are the entries? Or elements, whichever way, sometimes they'll write elements. At A3, 1, and A2, 2. Okay, so A3, 1 is what? 3. Row 1, 2, 3, column 1. It's right there. Okay. A2, 2, 4. Row 2, column 2. You want the 4. Okay. Now we're going to look at operations within these matrices. All right, so let's let matrix A be equal to a -2, 3, 0, 1. Matrix B is equal to 8, 4, 1, 4. Oh, that should be a 5. Okay. Now, to add or subtract matrices, the first requirement is the dimensions of the matrices you're adding together or subtracting must be the same. So matrix must have same dimensions in order to add or subtract the matrices. So that's the first thing you check. Make sure the dimensions are exactly the same, or you cannot add or subtract them. It's impossible. Okay? Then you're going to add or subtract, depending on which operation you're going to do, each corresponding element. Okay? So, in practice, let's say I wanted you to find A minus B. Okay, so that meant I'm going to be looking at matrix A, which is -2, 3, 0, 1. And I'm going to subtract matrix B, which is 8, 1, 5, 4. First question, what's the dimensions of matrix A? Okay, it's a 2 by 2. What's the dimensions of matrix B? 2 by 2. Can I add them together? Can I subtract them? Yes, they have the same dimensions. That's the first thing that we're checking there. Now, to figure out what this is equal to, I'm going to take each corresponding element. So I'm going to take this -2, which is in our first row, first column, and I'm going to subtract the first row, first column from the second matrix. And that answer is going to be my first row, first column in my answer matrix. So, what is -2 minus 8? So that gives us a -10. Then I'm going to repeat that for my next entry. So now I'm going to go my first row, second column, and I'm going to subtract my first row, second column, and that answer is going to go in my first row, second column in my answer matrix. And what do you get there? 2. Okay, so now I've done all the first row, so I move down to my second row. And I'm going to take my second row, first entry, subtract my second row, first entry here, and that's going to give me my second row, first entry in my answer matrix. So what do I get there? What was that? -5. And then orange. Okay. Now I'm going to take this entry here, which is our second row, second column. multiply by second row, second column, and that's going to give me my second row, second column answer here, which would be -3. You've done your first matrix operation. It's that simple. Okay, so now I want you to figure out B minus A. Matrix B is 8, 1, 5, 4, minus matrix A, -2, 3, 0, 1. So, what is going to be my answer matrix? What's my first row? 10,
-2.
and -2. So I take 8 minus a -2, which becomes +2, gave us 10. And 1 minus 3 gives us -2. And what's our second row? 5 and what?
3.
3. 5 minus 0 is 5. 4 minus 1 is 3. That's it. You're done. Okay. So that would be matrix adding and subtracting. Then we're going, our next operation we're going to look at is scalar multiplication. And that just means multiplying a matrix by some number. That's all scalar multiplication means. So let's say, and I have, let's find 3A. So again, my matrix A is, you all can see it, -2, 3, 0, 1. Okay. And so I want to find 3A. So that tells me I need to take 3 and times it by matrix A. Okay. To do this, you're going to distribute that scalar to every single element in the matrix. So I'm just going to do, to get my first row, first column entry, I'm going to take 3 times -2, which gives us -6. To get my first row, second column, I'm going to take 3 times 3, which is 9. What would the bottom row be? 0 and 3. That's scalar multiplication. So A was this. What was our B again? B is 8, 1, 5, 4. Thank you. 8, 1, 5, 4. I want you to find 4B minus 2A. So we're going to put scalar multiplication together with our adding and subtracting. So find 4B minus 2A. This topic here, this matrix operation topic here will be a non-calculator topic. All of the following topics where we're going to do systems of equations, all that stuff, we'll be able to use our matrices and use our calculators in the matrix operation in the calculator. But for the first one, this one's going to be a non-calculator quiz. Okay, 4 times B, what'd you end up with for your first row? And second row? 20 and what? 16. Now, the next one you can choose. Some people like to distribute the -2. If you distribute the -2, you got to put a plus sign and add. I tend to keep the negative and then just distribute the 2. But it's your personal preference which one you want. So if I keep the negative in between, I'm just going to distribute 2 to everything. What do I end up with? Okay. So I need to see this intermediate step. So this is the first one that has a lot of work to do at first. I need to see that intermediate step on your work. Okay, so that would be part of your work to show. And then you can get to your answer matrix. What would be your first row? 36. So take -2 minus a -4 becomes 32 plus 4. I said that wrong first. Okay, next one. -2. Bottom row. How would y'all do? Okay, go to Canvas. Open up our matrix assignment and the quizzes and complete questions 1 through 8. 1 through 8. Then stop at 8 after you get 8 done. All right, so now let's look at matrix multiplication or multiplication of matrices. So unlike the scalar multiplication, we just multiply by a number. In matrix multiplication, we'll be multiplying 2 matrices together. So a matrix A times a matrix B is what we'll be doing on this one. So let's say I was given matrix A is equal to -1, 2, 3. And second row is 4, 0, 5. And matrix B is defined by 5, -1, -4, 0, 2, and 3. Now, the rules about when you can or cannot do matrix multiplication are different than adding and subtracting. What was our rule for adding and subtracting? They have to have the same dimensions. So the matrix has to have the same dimensions. But for multiplication, okay, the column number, the number of columns in the first matrix, so first matrix, number of columns must equal the number of rows in the second matrix. Okay, let me explain what that means. Let's say if I wanted to find AB, or this test is see if I could figure out AB, if it's possible. Okay, I would look at the dimensions of A. What's our dimensions of A? This is a 2 by 3. That means it has 2 rows and 3 columns. What's the dimensions of B? Is a 3 by 2. If these two numbers are the same, you may multiply. There is possible to multiply. If those two numbers are different, you cannot multiply. So that's the easy way of doing that. It just looks complicated there. So basically, identify the dimensions of each of the matrices and make sure that the ending of your first matrix is the same as the beginning of your second matrix. So the column of the first has equal the row number of the second. Okay, so that's the key that you have to do on this. And this is cool. Your answer matrix will be a dimension of 2 by 2. The outside tells you what the dimension of your answer matrix will be. So when I multiply this 2 by 3 by 3 by 2, and I can do it, my answer is going to be a 2 by 2 matrix. Okay. So let's do A times B. So I'm going to write this one out. And it's very helpful that if you do write this out. So I got matrix A. And I'm going to times this by matrix B. Now, how we're going to do this, we're going to go across the first row and down the first column. Across the first row and down the first column is the order in which we're going to do this. So that tells us that I need to take this times this number is the first operation I'm going to do. And this one you have to show intermediate steps. So I'm going to have negative 1 times 5. What does that give us? It gives us a negative 5. Plus, and this is still in my first row, first column entry. Okay. Now I'm going to do plus this number times this number. Okay, so what's 2 times a negative 4? So add a negative 8. Plus, continue going across and down. So now I got to take 3 times 2. What does that give us? 6. And I've done all the way across the first row, first column. So this answer here is going to be my entire first row, first column answer when I simplify that down. And now I'm going to go and I'm going to move on to first row, second column. So I take the first number here times the first number here. What does that give us? 1 plus, move over and down. 2 times 0, 0, plus, move over and down. 3 times 3, 9. I've done all of my first row, second column. So this is going to be my entry for my first row, second column. Then I move, now I've gone all the way across, so now I need to move to the second row. So I'm going to take my second row and times it by my first column. So 4 times 5, 20. Move over and down. So 0 times a negative 4, 0. Plus, move over and down. 5 times 2, 10. I've done now my complete first row, first column. So that will correspond to this entry that we get here. Now I'm going to move to my second row, second column. What do I add together? Negative 4 plus, what's our next point? 0. So I take 0 times 0 plus 15. I want to see this step, the intermediate step here. Then I can get to my answer matrix. I just combine each of these elements. So my first row, first column, what is negative 5 minus 8 plus 6? Okay. And then my second row, second column. First row, second column. 10. Second row, first column. 30. And the last entry. 11. That is A times B. All right, now find, if possible, B times A. Let's see if it's the same thing. Because I know 2 times 3 is the same as 3 times 2. I wonder if I take A, matrix A times matrix B, am I going to get the same as B times A? So we want to find B, A. So I'll give you a moment to do that. There's your A and B again, if possible. Actually, those right there in that big cup, there's a lot of them. Okay, so can I figure out B times A? Yes. What's our dimension of B? That's a 3 by 2, and the dimensions of A? 3 by 3. So yes, I can do it. What's my answer matrix size? Is it going to be a 3 by 3? Okay. So to do this, I need to start over and down. So I'm going to do my first row in my first column. So 5 times the -1 gives us -5 plus a -4. Okay, so I go over and down. That's my entry for my first row, first column. And I'm going to do my first row, second column entry. What am I going to be adding together? 10 plus 0. First row, third column, what will we be adding together? 15 plus what? -5. 5 times 3 times a -1 times 5. So, okay, now I've finished all the way across. So now I'm going to go to my second row and start my first column. So -4 times a -1 gives us plus what are we doing? I'm taking this times this, give me the 4, then I must move over and I move down. So what's 4 times 0? 0. Just always go over and down. Right? And so now I'm taking the -4 times by the 2. What does that give us? -8. And then I'm going to take the 0 times 0. And what does that give us? 0 times 0? No, I can't do the easy ones. All right. First, second row, third column. What am I going to be adding together? -12 plus 0. Okay. Third row, first column. What will I add together? Plus 12. 2 times a -1. This is -2. Then I go over and I go down. 4 times 3. Always remember over, down. All right. So next one. 4 plus 0. And last entry, 6 plus 15. So my final answer matrix would be what? So is B times A equal to A times B? No, order makes a difference in matrix multiplication. So be very careful in the order in which they stay in. You do not get the same answer. In fact, sometimes you can do it one way, but it's impossible the other way. Okay, now go ahead and go back to the assignment and start on question 9 and go all the way until question 13. 9 through 13. Okay, next section, we're going to look at, it's okay if you don't finish. I just want to make sure I have time to go over this. I have some that are getting close to being finished or done. And so for the next section, you're going to do matrix equations. And what this is set up is that we're going to find out, we're going to have a matrix equal to a matrix. And then once you get a matrix equal to a matrix, every corresponding entry is equal to the corresponding entry in the other matrix. So what I mean by this time I don't have a single matrix on the left-hand side. So to get a matrix equal to a matrix, I need to first do this addition operation. So doing that addition operation, I would get x plus 3y as my first entry of this. Because I can add these because this is a 2 by 1 and this is a 2 by 1. So they have the same dimensions. And then in my second entry, I have 7 plus a negative x, that's 7 minus x. So that would what be that matrix would equal to, if I add those matrices together. And that's that equal to this matrix of 16 over 12. So now I have a matrix equal to a matrix. If you have a matrix equal to a matrix, each corresponding entry must be equal to each other. So that meant this entry here in this first row, first column must equal the entry in this first row, first column. So therefore, I know that x plus 3y is equal to 16. I also know that this entry here, which is in the second row, first column, must equal this entry here, which is in the second row, first column. So I could say, I know that 7 minus x is equal to 12. And so now you look at what you have and solve for your variables. So we want to solve each of these equations for a variable. We want to start with the bottom one this time. So we want to solve this for x. So what can I do to get x by itself? All right, so subtract the 7 from the 12 and I get 5. But I want to know what x is. So divide by negative. And I know x is equal to negative 5. So I solve for x. Now I'm going to take that number and replace x with negative 5 up here in the other equation. And that'll allow me now to solve for my y variable. So to get to the y variable, I have 3y is equal to what, 16 plus 5? What was that? 21. And therefore, y must be what? 7. So I've solved for x and solved for y. So corresponding entries are equal to corresponding entries. You have matrix equals to a matrix. And that's all you do for this type. So give you a little bit longer, but you can finish up the multiplication if you haven't finished up the multiplication, but the ones that are done, you go on, move on to the find the variable section, which is now problem number 17. In a second. Okay, so this is our first situation that we're going to look at. At a particular swim meet, 7 points were awarded for each first place finish, 4 points for each second place finish, and 2 points for each third place finish. Which team should win the meet? Okay, so this is one application of matrices that you could use. It lets us easily organize our data into entry forms. And so I can identify one matrix, which I could call my school matrix, I guess, or my result matrix. We'll do results. Okay. So we can call this our result matrix. So I'll use R to represent my result matrix. Now in this matrix, I'm going to put all of Franklin School results on the first row, all of Hayes School results on the second row, and all of Lincoln School results on the third row. So working with word problems, it helps you to make sure you identify what's being measured in each row and each column so that you know exactly what's being measured for every element, what every element is telling you. And then I'm going to put across in my my columns, I'm going to do how many first place winners we had, how many second place winners, and then how many third place winners. So for Franklin, there was 8 first place winners, 9 second place, and 1 third. For Hayes High School, there was 8, 5, and 3. And for Lincoln's, there was 3, 3, and 6. So I can easily identify this as a matrix, that 3 by 3 matrix there. And that lets me identify. I put these labels on there so I can know that this entry 5 here represents the number of second place winners at Hayes High School. So it helps you to always label your rows and your columns. Now, I want to also talk about points. So I'm going to do another matrix. I'm going to call this my points matrix. And on here, I'm going to figure out how many points they are. But I have to first make a decision. Should I do the points as a row matrix? This is called a row matrix. It only has one row, where I do my first place here, my second place, and my third place here. In first place, we get 7 points. Second place, we get 4 points. Third place, we get 2. Or should I make my points matrix a column matrix where I do my first place here, second place here, and third place here? So 7 points for first place, 4 points here, or 2 points here. How can I decide which one it should be? Okay, so you're thinking, okay, we're probably going to have to multiply our columns, and we need this to be by the same as our rows, so it might need to be shaped like this, so I can have over and down. Why would we multiply?
Because they have like
so we know for each first place, we need to give them 7 points for each of those. So I need to take 8 times 7. And each of these 9 places, they need to get 4 points for each of those second places. And so I do need multiplication. So that's the next thing you have to recognize. So this is incorrect. So matrix B, my points matrix needs to be a column matrix. And that's exactly the reason why, because I need to, in order to figure out who won the meet, I need to figure out the total points earned for each school. And so to figure out the total points earned for each school, back to it. There you go. To get the total points earned from each school, I need to figure out P times R. Oh, sorry, R times P. The results times the points earned. So I'm going to be calculating 8, 9, 1, 10, 5, 3, 3, 3, 6, times by 7, 4, 2, to get our answer matrix here. So let's do that. Let's make sure. What's the dimensions of the first matrix are? What was that? That's a 3 by 3. And what's the dimensions of matrix P? 3 by 1. So I can multiply it. What's my answer matrix going to look like? 3 by 1. All right, so working this out. 8 times 7, 56, plus 9 times 4, 30 what? Plus 2. Okay, I've gone all the way over and down, so now I need to do second row, first column. What do we get? Plus. Not 6. Oh yeah, 6, sorry. Plus 6. Okay. And then third row, first column. And let's add that each of those together. 56 plus 36 plus 2. 94. Okay, 70 plus 20 plus 6. 96. 21 plus 12 plus 12. 45. Okay. What does this 94 mean? Who has 94 points? So Franklin earned 94 points at the meet. Okay? Who won the meet? Hayes. Hayes got the highest points. The highest points won the meet. Hayes won the meet. And that would be it. So you got to make sure you answer the final question. Hayes won the meet. Okay, so that's the rest of it. So now you can do the remaining few problems where it's working out these. And you have until Tuesday night to get that completed.